Welcome all to this new lecture series of non-destructive testing. In this lecture series, we will discuss non-destructive testing from its theory as well as from its application perspective. We will discuss in detail each non-destructive testing technique, their theory, and how they can be applied practically. So this first lecture will be an introductory lecture in which we will see that what is the need of non-destructive testing and why actually we should worry about it. So if we have to define non-destructive testing, then it can be defined as a process of inspecting, testing, or evaluating either materials or components or assemblies for any discontinuities. These discontinuities can be a flaw, can be a crack, and during inspection, it should not destroy the serviceability of the part. So means if we have to define it in simple terms, then it is the process of testing a component for any type of crack or flaw, and after the testing the component should be used wherever it was in use before the testing. So one important point here is that after the inspection the part still can be used. So that is why it is known as the non-destructive testing. Means the testing technique which we are using is non-destructive in nature, means that is not destroying or affecting the workability of the component or part or the assembly. So these NDT is also known by some other names like non-destructive inspection NDI or non-destructive evaluation NDE. So here you can see these two photographs where this on the left hand side one guy is checking the railway tracks with some kind of sensor and a monitor within his hand, and other one is also checking this thick metal plate with some kind of sensors. So here we will see that what are these sensors and how they can be used and in what on what principles they work. So if we have to discuss some important points about non-destructive testing, then these important points are as follows. So in non-destructive testing we have to find out or detect defects that may have arisen in manufacturing or in service of the part. So likewise welding, this is the uh, in welding it is a manufacturing process, so defect can be introduced during welding or either during corrosion and fatigue. So these are the if defect is produced from corrosion or fatigue, then this is known as an in service defect. So means manufacturing and service, we have to take these two things into consideration and we have to detect flaws either in manufacturing or in service or in both these stages. We have to check our component and we should be able to determine the exact nature of the crack because that determines the performance of the component. And the foremost step which is generally used in non-destructive testing is visual inspection. Means we have to see from our naked eyes that whether there is any visible discontinuity on the surface of the part or not. And in order to enhance the workability of the visual inspection, there are some techniques which have been developed on some very basic physical principles like electromagnetism. So and these techniques which are developed on the basis of these simple principles are known as the non-destructive testing techniques, which will be discussed in detail. And when a product is designed or is manufactured, so firstly it has been designed by some engineer or designer, so he should specify that what kind of defects can arise in that particular component, so that without wasting much time we can use one particular type of NDT technique. And If there is a failure to detect flaws, then that failure can lead to serious impaired service performance, and that can also lead to the failure of the component, which can be economic loss as well as can also cost human lives. So uncertainties such as human intervention should be taken into consideration, because all these techniques are performed by some technicians, so that factor should be taken into consideration. So NDT actually is a technique which we are very much familiar with, and it is a widely used technique in our in our daily routine. So if we take the example of shopping goods which are made up of ceramics, then generally what we we do the visual inspection. We see that whether there is a crack or any flaw on the surface of that ceramic component. So if there is any crack or flaw, so we will not generally select that item. So this visual inspection on this entity is taken into consideration while we are dealing with objects such as paintings, sculptures, furnitures, pottery, and ceramics. So likewise, here you can see these photographs where these are pots made up of clay or ceramic material, and these are made up of plastic. So whenever you will go to purchase these, so you check either by tapping on these ceramic pots, or either by bending these plastic containers, so that you are able to check, okay, this part will perform better when I will use it or not. And the another examples is the example of hawkers you might have seen on the streets, which demonstrate the good workability of their part. So suppose they are selling the plastic goods, so they will bend their plastic goods in to and fro directions, and will let you know that how much superior their product is. So actually what they are doing, so they are doing the non-destructive testing, means they are checking the component that if it is subjected to some kind of loads which are not which should not be there in during their proper functioning, so whether that will lead to failure or not. So this is the example of NDT in everyday life. So why we should worry about NDT? The bigger picture, if you will see, so here you can see there are failures, like failures of, you can see there's a failure of bridge, and there's a failure in aeroplane, and there's a oil platform failure, and here's a train you can see which has came off the line, and it has led to several casualties. So here if you will see this figure 1, so here one part of the bridge has been fallen down during heavy traffic, so which has killed 20 people and 30 people were injured. It happened in Seoul, South Korea. So here second figure is the famous failure which is known as the Aloha airline failures in 1988, where the whole fuselage has been blown up in the air. So fuselage is that area where the passenger sits. So during when this fuselage has been blown away, one air hostess has been thrown away by the wind pressure, and she has not been found till date. And here you can see this oil platform has been fallen down, and this train has been came off the line. So here you can see that these failures have happened because we have ignored some minute flaws in these um, infrastructures. Likewise, this bridge failure has been happened because there was some pin connections which has been broken down, and here there was a small crack in this airline, in the fuselage area of airline, which has been ignored. So here you can see that how these small cracks or discontinuity can lead to such catastrophic failure. So here you can see in this photograph, this person is taking down some uh, noting down the data of the type of failure which has occurred during the bursting of this pipe. So there are some other bridge failures. Likewise, the Silver Bridge failure in 1967 in USA, where a crack length of 0.1 inch has led to the casualties of 46 people. And here you can see this part of the bridge has been fallen down. And here this was the Florida International University Bridge, which has been fallen down, and it has led to 6 deaths and 8 injuries, where 8 vehicles have been crushed underneath. So this has happened in the daylight. So here the reason was the calculations in bridge design, as well as the lack of identification of structural cracks. So you can see from here that why it is important to check any uh, defects in a component while it is in the manufacturing phase, as well as in the as well as during its in service phase. So talking about India, there are several failures in India. So these train disasters you might have heard or have seen frequently or in news. So here are some of the failures which has been which I found from the Wikipedia and I have mentioned here. So this train disaster has led to the 57 casualties. Then there is a Rafiganj railway bridge failure. Then there was also a building collapse, and a residential building collapse, which has led to 61 dead and 32 injured. And there's a Vivekanand flyover bridge failure in Kolkata in 2016. So here you can see there are several examples of failures in India which has happened because of lack of inspection of the mm, components or the parts during their manufacturing, as well as in service phase. So in order to avoid these type of failures, we need to worry about the non-destructive testing. So there are some other types of failures uh, other than the bridge failure and building failure. So here you can see this is a radiographic image or X-ray image of a welding joint. Here is you can see these black color the spots. So these are the pores or flaws inside a welding joint. So this has been highlighted with this red circle. So these um, will grow over the period of time, and it can lead to the failure of this welding joint. So here you can see this is an integrated chip. So here when this current passes through these wires, so there is a heat generation in it. When the current changes its amplitude, there is a changes in heat generation, and it will lead to thermal loading. And due to that thermal loading, fatigue occurs, and sometimes these wires get broken. So here you can see if the nowadays many components, electronic components, the heart of those electronic devices is this integrated circuit chip. So here you can see that we need to take consideration we need to take into consideration that whether there is any discontinuity in the IC chip or not. And here you can see there's a hip implant. So here you can see when a person will walk, so there will be a cyclic loading, and due to that cyclic loading, it may happen that this implant may wear out with time, and it will not perform as it was supposed to be. So here you can see that other than the infrastructure failures such as building failure, train failure, or airline failures, there are other domains as well where we need to look nowadays as our technology is advancing for any type of defect, so that we can apply suitable techniques. So here the monitoring of the infrastructures is generally known as the structural health monitoring, which is a very different topic, and it is also a widely studied area, and people are also doing extensive research in it. So if we have to create a simple analogy, so when we humans feel something bad with our body, we go to the doctor. He use some kind of equipments, he does some diagnosis, and by that diagnosis the doctor give us some prescription. So that is the thing which we humans too, and it can be known as the human health monitoring. But unfortunately structures can't speak, so what we have to do, we have to mount some sensors, or we have to use some equipments. So these equipments will give us some data. We have to read that data, and from that data the engineers and experts can analyze, okay, if there is a flaw in any particular location of that infrastructure or not. Suppose if you're using sensor, you can mount sensor at some critical locations where you can see that from those locations there might be chances of failure. So well, you can observe continuous data, and when there is any change in the data, you can see that, okay, at that particular location there is some discontinuity, so you should go in person and check that part of that infrastructure. So it is known as the structural health monitoring, which is also a sub area of this non-destructive testing. So how these defects can arise in the material? So these defects either can arise in raw materials, during the manufacturing stage, during assembly, and in service conditions. So during raw materials, or we can understand it that during the production of casting, because when we make casting products, we have to subject them into some machining states also. So here in raw material or in the production of casting stage, there can be defects such as stress cracking, gas porosity, segregation, slag inclusions. These all can arise. So you do not need to worry about every type of defect. This slide is just to give you an feel that, okay, these type of defects can arise in our components. So during manufacturing there can be machining faults, heat treatment defects, welding defects, residual stress cracks, and in assembly, likewise, if there are missing parts, if you have done the incorrect assembled assembling, and there can be stress cracking also. And during corrosion, so during service, so in service defects, these are the important type of defects which we will study also, like fatigue, corrosion, stress corrosion, wear, creep, thermal instability. So fatigue, corrosion, and creep we will also study. So that these are the conditions, or these are the causes through which the in-service failure of components or assemblies generally happens. So here you can see that the a simple flaw and crack can create a havoc in the performance of an assembly, and we have to check these flaws and cracks at every stage, from starting from the raw materials to the in-service, and we have to figure out that where is the crack, and we have to use particular type of technique for detecting those cracks. And after detecting those cracks, we can use preventive measures. So these are the type of NDT methods which will be discussed in this lecture series, like visual inspection, liquid dye penetration, magnetic particle inspection, eddy current testing, ultrasonic testing, radiographic testing, acoustic emission, impedance based methods, and there are some also advanced methods. So here we will see these techniques in detail. So if you have to summarize NDT, so the first and most foremost important part is that the component or assembly which is subjected to testing can be used after the testing, means NDT does not destroy the part, and it is still fit for its service. And NDT gives the probability that a component is free of defects. It saves economic losses from catastrophic failures, and it also helps to save human lives. So not all flaws need rejections of the components, because some surface flaws can be removed during machining. So this is just an example that if there is any surface flaw, so during machining that can be easily removed. So we have to take this into consideration as well. So during deploying the NDT technique, so we should actually deploy NDT techniques before moving any part to the costly machine. So this is an important factor which we should consider, that before using any costly machine for the manufacturing of a part, we should deploy NDT technique so that the economic loss can be reduced. So deploying NDT technique incurs cost, but it also helps in financial savings. Likewise, we can see from point 3 how it can save us from economic and catastrophic failures, which we have seen from the uh, previous examples of failures, which has led to the several casualties. So we need a skilled operator and portable instrument. Either we can use fully automated system in production line, or portable instruments can also be used in NDT. So imposition of too many or too sensitive systems can be a waste of money and time. So we should be aware of the type of defect or flaws that can arise in our assembly or in our component. Then accordingly we should use the NDT technique, means on the severity of the crack and how that crack can affect the in-service condition of the component, we should use a particular type of technique. So this was all about NDT in terms of introduction. So thank you.